Hello students, this is Mr. Bornheimer, and today we're going to be talking about significant figures. Okay, now significant figures are important for a variety of reasons in science and mathematics. They give us insight into how accurate a particular measurement is. Um, Now there are some things about significant figures that are gonna might confuse you at first, but if you take your time to watch this entire presentation, hopefully all of those will be clarified. First of all, significant figures are essentially digits in a number. Okay, so if I had like a number like 1, 2, 3, each of these are digits, and what there are certain rules that govern what is significant and what is not. Okay, so if we go to the next slide here, we'll look at several different examples. First of all, our first example would be any non-zero number is significant. Okay, so an example of any non-zero number could be like 123 or 5 or maybe, and I'll just separate out these examples, or maybe 63. Okay, all of these are non-zero numbers, so they're all significant. This particular example here, 1, 2, 3, would have 3 significant figures. Okay, whereas this 5 would have 1 significant figure, and the 63 would have 2 significant figures. And we'll call them sig figs. Okay, so there's a variety of different ways that we can see any non-zero number, and ultimately it's just 1 through 9. If there's a 1 through 9 present, it's significant. Okay, so like this one here, 3 sig figs, 1 sig fig, 2 sig figs. The second rule governs what I like to call sandwiches. Okay, so I'm just going to label it sandwiches. And that is when there's essentially, more scientifically, any zero that is trapped between non-zero numbers. Okay? Any zero that is trapped between non-zero numbers. Okay, this kind of sandwich would be like 103. This zero is sandwiched between the 1 and the 3, therefore it is significant. Okay? Um, So yeah, and that can be a variety of, you can see a variety of examples like this. For instance, 2005, 2005. Both zeros are trapped, therefore it's a mega sandwich. But it means that all 4 of these numbers are significant, so there would be 4 sig figs. Okay, so there's 2 of the rules. All right, and we're going to go ahead and go to the next page. We'll look at rule, and we'll change our pen here. Let's use red. Then there's the third rule. And the third rule talks about final zeros after a decimal point are significant. Now, the final zeros after a decimal point are significant rule can be one of the more tricky ones because the zeros are kind of on the outside. They're not trapped. That's easy to see. Okay, and in like the first rule, there is no zeros. This one is a little trickier. An example of final zeros after a decimal point would be 1.0. Notice that the 0 is after the decimal point, to the right of the decimal point. Okay, so the 0 is to the right. And it's a final 0. Okay, so it's on the end. Other examples, this might be 1.0350. There's a final 0 after the decimal point. Or 2.70, final 0 after the decimal point. They are significant. We actually also have a sandwich in here too. All right. In this particular example, you'd have 5 sig figs. And in this particular example, you'd have 3 sig figs. Okay. So there is the third rule. The fourth rule governs what is not significant. Okay, so what is not significant? An example of this would be, and we're going to need a new page. Let's see here real quick. An example of what is not significant are place-holding zeros or spacing zeros. So rule number 4 is placeholders placeholding zeros are not significant. Okay, examples of this would be 0.000186. These zeros here and this one are placeholders. They're just there to push this 186 further below 1. So therefore, the 186 is significant because they are non-zero numbers, but these zeros are spacers, and therefore they're not significant. So in this particular example, there are only 3 significant figures. Okay, and another example of this might be 16,000. 16 is significant, but the 3 zeros that push it out into the thousands place are not. They're just placeholders. They're just taking and pushing the 16 out further. So therefore, this would only have 2 significant figures. Okay, so these are rules, basic rules for understanding significant figures. And we can go ahead and we'll go to the last slide here, and we'll just kind of look at some examples and try to use these 4 rules to identify what is significant and what is not. So we're going to go ahead and with a different color here, we're going to go ahead and look at 6 examples. So the first one is going to be 1.034. The next one is going to be 70. The next one is going to be 100.05. The next one is going to be 7.030. The next one is going to be 64,350. And the last example is going to be 0.0025. And we're going to look at significant figures for all of these. Okay, first of all, here, we know that the 1, the 3, and the 4 have to be significant. But this 0, we have to recognize, is it significant or not? In this particular case, and you may have already guessed it, it's a sandwich. It's stuck between 2 non-zero significant numbers. Therefore, it is significant. That means all 4 of these are significant. So we have 4 sig figs. Okay, here we have no apparent decimal, but there is one. This is a final 0, but it's not after our imaginary decimal point. Okay? Therefore, because it's on the end and it's not after our imaginary decimal point, it's not significant. So we only have one significant figure here, and that would be the 0. And so therefore, we have 1 sig fig. Now down here, we have a lot of zeros. We even have one after the decimal, one before the decimal, but the real key here is the 1 and the 5. They are both significant, creating a rather large sandwich between 2 non-zero numbers. So all the numbers in between and all the zeros because they happen to be zeros, are significant. So we have 1, 2, 3, 4, 5 different numbers or places. So we have 5 significant figures. Now up here, we have 2 zeros. One is a sandwich, and one is an end or final zero after the decimal point. Both qualify as significant, as does the 7 and the 3. So we have 4 significant figures. Now, here, we have a 6, a 4, a 3, and a 5. We know for sure those have to be significant. But the 0 is to the left of the decimal. Therefore, it's a placeholder. It's just there to push the 6, 4, 3, and 5 out into the tens of thousands place. Therefore, there's only 4 significant figures here because the 0 is a placeholder. And now we have this last example. And we have 3 zeros, a 2, and a 5. Now, the zeros here are not sandwiched. They're not final zeros after a decimal point because they're not at the end of the number. Therefore, they have to be placeholder zeros, and they are. They're there to push this 2, 5 further below 1 into the hundreds and the tenth or the thousands and the 10,000s place. So, therefore, there's only 2 sig figs here. These 2. Okay, now a couple of reasons why we use significant figures, because some people are, when they first learn about significant figures, are like, why do we need these? Seems like a bunch of rules that scientists made up to make life hard. And that is not true. The reason we use sig figs is because they give us more accurate and precise information about our measurements. Okay, first of all, any measurement is only good as the tools that measured the quantity. Any measurement is only good as the tools that measured the quantity. So for instance, a meter stick, okay? A meter stick is only good to the half millimeter mark. Beyond that, we can't get any accurate information about more fine measurement. Let's say hundredths of a millimeter or thousandths of a millimeter. A meter stick is limited in the measurement in its measurement capabilities. Okay, significant figures tell us something about the measurements that are present. For instance, 2.0 and 2 are different numbers. Sometimes my students have a hard time with this. 2.0 tells us something entirely different about what measured it than 2 does. 2.0 says that whatever measured that measurement is good to the tenths place. Okay, 2.0 is good to the tenths. Whereas 2, okay, there's nothing about tenths or hundredths indicated in the number, so it's only good to the ones spot. Okay, so 2 is only good to the ones place. Now, this means that 2.0 was made with an instrument that had more precise information about or had more precise measurement. It could measure to a greater degree. Whereas the 2 here is a little bit more of a broad or less precise device or measurement. It can't necessarily measure as far as the 2.0 or the device that measured the 2.0. Okay, so it all comes down to the numbers telling us something about the measurement. For scientists, this is incredibly important because oftentimes we try to repeat other scientists' experiments. By looking at their measurements, we're able to tell something about what the instrumentation they had, and how accurate or precise their instrumentation was. So the significant figures aren't just there to be cumbersome or confusing, they're there to tell something about the measurement. And ultimately, that is very important in science when we're trying to repeat experiments or publish work or collaborate to solve a problem. We really need to know what it was that measured something in case we need to repeat the experiment or need it, you know, checked by another scientist. So that's what I have on significant figures. And if you have any questions, you can always email me and or check out my channel or Google Plus page. So thank you and goodbye.